Okay, Assalamualaikum guys. So today, we go to inverse hyperbolic function. Okay, so previously, we have looked hyperbolic function. Then today we start to look inverse hyperbolic function. So today, we learn about definition of inverse hyperbolic function and then how differentiation of inverse hyperbolic functions. Okay, so this is the learning objectives. Alright, so next, definition of inverse hyperbolic functions. Okay, the inverse hyperbolic functions can be expressed in its natural logarithmic form. Okay, we present the definition of inverse hyperbolic functions below. Okay, so this is the table of definition of inverse hyperbolic function. So sine hyperbolic inverse x is equal to ln x plus square root x squared plus 1. Okay, cos hyperbolic inverse x equal to ln x plus square root x squared minus 1. Okay, tangent hyperbolic inverse x equal to 1 over 2 ln 1 minus x over 1 plus x. Okay, cotangent, 1 over 2 ln 1 plus x over 1 minus x. Alright, secant hyperbolic inverse x, we have cos hyperbolic inverse x 1 over x. Okay, cos secant hyperbolic inverse x equal to sine hyperbolic inverse 1 over x. Okay, so this is the definition. Alright, so for example, number 1, without using calculator, find the value of tangent hyperbolic inverse sine hyperbolic ln 2. Okay, so how to find? Okay, the first step is you have to find the value here. Okay, what is the value for sine hyperbolic ln 2? Okay, so we use the definition of sine hyperbolic. Okay, so what is the definition of sine hyperbolic? So we know that sine hyperbolic x equal to exponent x minus exponent negative x over 2. Okay, so find the value here first. So we have sine hyperbolic ln 2. So it's equal to exponent ln 2 minus exponent negative ln 2 over 2. Okay, alright, so simplify, become 2 minus 1 over 2 over 2. So the answer is 3 over 4. Okay, so substitute into our tangent hyperbolic. Alright, so our tangent hyperbolic inverse sine hyperbolic ln 2 is equal to tangent hyperbolic inverse 3 over 4. Okay, so next we use the definition of tangent hyperbolic inverse. So what is the definition of tangent hyperbolic inverse? So tangent hyperbolic inverse x is equal to 1 over 2 ln 1 plus x over 1 minus x. Okay, so is equal to, saya masuk dalam formula 1 over 2 ln 1 plus 3 over 4 over 1 minus 3 over 4. Okay, so it become 1 over 2 ln 7. Okay, or we can write as ln 7 power of half or ln square root 7. Okay, alright, so next, so exercise. So without using calculator, find the exact values. Try find the values of the equations yourself. Okay, without using calculator, but using the definition of hyperbolic and sine and hyperbolic inverse. So kena guna dua-dua. Right? So cari Alright. So next, okay, we go to differentiation of inverse hyperbolic function. So the differentiation of inverse. So the table is, if we differentiate sine hyperbolic inverse x, so we get 1 over square root x squared plus 1. Okay. Differentiate cos hyperbolic inverse x. Okay, we get 1 over square root x squared minus 1. Okay. Differentiate tangent hyperbolic inverse x, become 1 over 1 minus x squared. Okay. Then cotangent hyperbolic inverse x equal to 1 over 1 minus x squared. Okay. Secant hyperbolic inverse x and cosecant hyperbolic inverse x. Okay. So next we go to the example. Okay, so example find the derivatives. So for A, y equal to cos hyperbolic inverse 3x minus sine hyperbolic inverse x cubed. So find dy dx. So what is dy dx for A? So dy dx equal to, okay, differentiate cos hyperbolic inverse 3x. Okay, using the table, we know that differentiate cos hyperbolic inverse become 1 over, okay, square root 3x square minus 1, okay, times 3 minus, okay, differentiate sine hyperbolic become 1 over square root x cube, okay, square plus 1 times 3x square, right? Simplify, so we get 3 over square root, ni pun boleh simplify ni, 9x square minus 1 minus, okay, 3x square over square root x power of 6 plus 1. Okay, so this is the answer for A. Okay, for B, you can do it yourself. I'm giving you the answers. So dy dx is equal to, okay, 2 over 1 minus 4x square. Okay, so next, C. Okay, C, we have y here. So we know that we have to use implicit differentiation. Okay, so we have sine hyperbolic inverse y equal to 1 plus sine hyperbolic inverse x. Okay, so using the formula, okay, we have to use the formula. Okay, so differentiate sine hyperbolic inverse y, okay, they become 1 over, okay, y square plus 1, so that is square root, times, okay, differentiate y dy dx, okay, equal to, differentiate 1 0, differentiate sine hyperbolic inverse x is become 1 over x square plus 1, okay, the square root. Okay, so how to find dy dx? Okay, dy dx is equal to, okay, square root y square plus 1 over square root x square plus 1. Okay, or we can write as square root y square plus 1 over x square plus 1. Okay, alright, D. Okay, D. Okay, D, you can do it yourself. So I'm giving you the answers. So dy dx is equal to 1 over, okay, square root 1 plus x square 1 minus 2 sine hyperbolic inverse x. Okay. Okay. Then E, y equal to tangent hyperbolic inverse x power of cos hyperbolic x. Yang ni saya buatkan So bila nampak dia ada kuasa function, So we have to use ln both side. Okay, saya buat kat atas. Saya buat E kat sini Right. So we have y equal to tangent hyperbolic inverse x power of cos hyperbolic x. So we ln both sides, so become ln y equal to ln tangent hyperbolic inverse x power of cos hyperbolic x. Okay, so we can write as cos hyperbolic x ln tangent hyperbolic inverse x. Alright, so from here we can continue our differentiation to find dy dx, but our right hand side become two functions. So this is our first function, this is our second function. So nak guna apa? We are using product rule. Okay, alright, so you can differentiate using product rule, but here I'm continue to differentiate without shows the u and v prime tu ya. So I differentiate ln y become 1 over y dy dx equal to, okay, so differentiate cos, okay, so remain cos hyperbolic x, differentiate ln 1 tangent hyperbolic inverse x, so become 1 over tangent hyperbolic inverse x time differentiate tangent become differentiate tangent inverse hyperbolic x become 1 over 1 minus x square, then differentiate itulah, okay, right, and then plus, okay, differentiate cos hyperbolic x becomes sin hyperbolic x, okay, times remain or ln tangent hyperbolic inverse x. Okay, okay, simplify, so become cos hyperbolic x over tangent hyperbolic inverse x times 1 minus x square plus sin hyperbolic x ln tangent hyperbolic inverse x. Okay, okay, saya sambung kat bawah, so that what is our dy dx equal to, okay, y darab dengan, okay, all the right hand side, cos hyperbolic x over tangent hyperbolic inverse x 1 minus x square plus sin hyperbolic x ln tangent inverse x. Okay, so this is the answer. Okay, alright, so okay, that's all for today. Thank you and see you next video.